Hello, this is Carson, and this will be the remake of the 2023 Invitational B number sense test since my last video was so unbelievably atrocious. I put all the answers in the answer blanks now, and I've provided methodologies to solve each problem to hopefully make things easier to follow. I'll also be going a lot slower. Let's begin. Okay, 315 divided by 9. You'll use a divide by 9 trick for this, where you first up add up all the digits, and then that value will be your fraction, so 9 over 9. That means you don't have a fraction and instead carry a 1. And then you do the same, but for only these two digits. So 3 plus 1, and then that 1 you carried over, and that's your 5 right here. Then you just have this 3 left over, so you put a 3 there. Okay, 2102 times 3. Just multiply each digit, 3606. This one, you can imagine the 0.23 is the same as both, so we can ignore it. And since the negative is greater, we can kind of imagine 311 minus 210 and making that negative instead. In subtraction, you always want to subtract the bigger number by the smaller number, and then make it negative if needed. So this is 101. Make it negative to be negative 101. Number 4, just add up all the digits. Not too hard. You got that. 23, you can either have this memorized or foiled. 3 squared is equal to 9. That's your 1. 2 times 3 times 2 is 12. 2, carry a 1. 2 times 2 is 4. Plus 1 is 5. 529. Okay, 13 over 20 is equal to, if you multiply the numerator and denominator by 5, you get 65 over 100, which is 65%. Okay, 7, use your 11th trick. Start with this 1, or start with this 3 right here. That's your 1's place. Add up this 3 and this 2. That's your 10's place. Add up this 10 and this 100. That's your 100's place. And then you just have this 1 left. So 1. So you can see that mapped out down here. This, then it's not too hard to prove. I'm not going to be going over proofs in this video. If you want those, you can ask me in person if it helps you remember them, or you can prove it yourself. Some things like this are extremely easy to prove, right? You're just multiplying each digit by 1. So you're basically just adding them. Number 8, this divided by 100, 2.1 minus 1 is 1.1. Easy enough. Number 9, you need to convert these to fractions with a proper base. So that common base is 12 in this case, or 3 times 4. So 2 and 2/8 plus 3 and 3/9. Add up the fractional parts, 17 over 12. So 5 over 12 with an extra 1 carried over. Okay, this, as you can see, this 23 is kind of irrelevant, and this is approximate, can be imagined as 23 times 24 with an extra 0 that needs to be added on later. 23 squared is 529, an extra 23 on that, it's like 5,500. You don't need to be super precise, or 550, and then you add on the 0 before. 11, you can FOIL this, it's not too bad. 2 times 1 is 2, that's your 1's place. 2 times 4 plus 1 times 1 is 9. 2 times 1 plus 1 times 4 is 6. 1 times 1 is 1. Or you can also imagine it as 144 minus 3 times 12. So you should know 12 cubed is 1728, and then you're subtracting 36 from that. 12, multiplying everything, this is just 32 plus 16 minus 32, so just 16. Okay, Roman numerals. M is worth 1,000, X is worth 10, and 1 is worth, and these I's are worth 1. So 2,023 times 2, 4,046. Smallest prime divisor of this, well, 21 squared is 3 times 7 squared. So your smallest prime divisor is just 3. 5 over 4 is what percent of 10? Well, to do that, you take your 5 over 4, divide it by 10. 5, you can rearrange that to make things easier. 5 over 10 over 4, so 1 over 8. And then put that into percent. You can multiply the numerator by 100, 100 over 8, or just have 1 over 8 memorized. or you probably already know what 1 over 8 is. It's not too hard. 90 divided by this thing, well, this is just 9 over 99 given our repeating series rules, because the 0, 9 repeats, so 0, 9 over 99. So you're really just dividing by 1 over 11. So you're just doing 90 times 11, which obviously has a remainder of 0. Okay, 17. You have stuff being multiplied and have stuff dividing. You can cancel out one of these 6's and one of these 4's because you're dividing by it. And you're just left with 6 times 25. And you get 150 from that. Okay, 2/3 of 6 feet, 9 inches is how many inches? Convert this to inches. 6 times 12 plus 9 is 81. And then multiply by 2/3. 81 over 3 is 27 times 2 is 54. Okay, 19. This is your difference in squares. Difference of squares is the sum of these two values times the difference between these two values. So 80 times 8. And you have to rearrange that to fit this format. Divide by 2, multiply by 2, 40 times 16. Okay, 210 times 311. This is pretty close to 21 times 31 with 2 zeros you have to add on, which is also pretty close to 20 times 30, 600, plus a 20, plus a 30, because how would I view it? 21 times 30 is 600 plus an extra 30, because of this one, and then same thing applies for the 20. So it's pretty close to this right here, if that made any sense. So you have 65 and 65000, and then you're adding 2000, so 67000. I think you'd still be in range even if you didn't do that. Let me just check. Yeah, you'd still be in range even if you completely ignored this 2000, but it's kind of relevant to the problem, and you might not be able to get away with that every time. Okay, 210 plus that divided by 4 is a remainder of what? Remainder of 4, you take the last two digits and figure out what the remainder when that divided by 4 is. So 10 mod 4, or remainder when divided by 4 is 2, plus 23 mod 4, 3. So 2 plus 3 is 5, mod 4 is 1. And mod is the same thing as remainder, by the way, in case you didn't know. 22. 20 minus 40% of 60. Well, 40%, 40 over 100, or 2 over 5. 60 over 5 times 2 is 24. 20 minus 24 is negative 4. Okay, 23. You can pretty much, it's pretty common when they give you these humongous squares that you're going to be using the I don't know the name of it, but you multiply it by your end value by 101. Oops. But what you do is, first off, the tens value of one number and the ones value of another number has to add up to 10. So 7 plus 3 is equal to 10. And then the ones value of that, I have one number, or that number has to be greater than 1 plus the tenth value of another number. So 7 is equal to 6 plus 1. That checks out. And then, once you do that, you do the number with the ones, 1 greater than the tens. So this number right here, you square each digit. 49 plus 49 is 98, and then multiply by 101. And that's proof that I don't remember if they prove it in the Brian Heath booklet. You can do it yourself if you want, or I can probably guide you through it if you talk to me in person, because it is kind of hard to remember. And I do like to prove things in order to help me remember them. If x is equal to 3, then x powered to 4 minus 4x squared plus 4 is equal to what? Well, this is x squared minus 2. You can imagine if this was x squared, this was x, and this was 4, it would be more obvious, x minus 2 squared. But all the x values are are squared, so x squared minus 2 instead. So that's just 7 power to 2 is 49. Discriminant of this, discriminant is b squared minus 4ac. It's what happens inside the square root of the quadratic formula. 49 minus 4 times 6 is 25. This base 10 is how much in base 5? Well, how bases work is that this value is worth 1, this value is worth 5, this value is worth 5 squared, and this value, if there was more, would be worth 5 cubed, etc. That's how these bases work. So how many times does 25 go into 81? Well, 3. Right at 3, you have 6 left over. How many times does 5 go into 6? Once. You have 1 left over. And that 1 is just left over, so you can put it right there. How many times does 1 go into 1? Like, come on. Okay, 54 times 54. This is your 10s add up to 10 rule with the 1s being the same thing. So in that case, what you do is, because this 4 times 5 plus 4 times 5 gets you 40, so at 40 would apply right here. So basically what you're doing is you square the ones place, write it down, 16. Then you multiply this 5 by this 5, and then add the 4. Because you basically have 4 squared plus 400 plus 2500, because the 4 times 50 plus 4 times 50 is equal to 4 times 100. So yeah, that's how you get that. Okay, 28, 4 3/5 times 6 3/5 is what? Well, first off, like always, multiply the whole numbers. 4 times 6 gets you 24. And then these two, what 6 and 4 are being multiplied by the same 3/5, so you can add them, 4 plus 6, and get 10 times 3/5. So 10/5 times 3 is 6. So now your whole number is 24 plus 6. 30 and 9/25, because you're just multiplying the fractions now. Area of an equilateral triangle with a side length of that is what? Find K. Well, area of an equilateral triangle is side squared over 4 times square root of 3, or more useful in number sense, this side over 2 all squared times square root of 3. So in this case, it's 3 squared is equal to 9. 30. This is basically asking what's the geometric mean of this, which is pretty close to the arithmetic mean, or just the average of the values. So 275. The actual answer is like 270 or something. But in these cases, you can often just take the square root of the average of the values, and maybe make it a little bit lower if you need to. So this, okay, if this 0 wasn't here, it would be your 20 repeating 25, so 25 over 99. But since it's here, you divide by 10, so you have 25 over 990. And then if you divide numerator and denominator by 5, you get 5 over 198, and you can't simplify any further. 32, this is similar to the 10s adding up to 10 trick. This is the 1s adding up to 10 with the same 10. So the logic behind it is the same. So multiply the 1s. 1 times 9 gets you 9, so 0, 9. And then you multiply your 4 times your 4 plus 1, so 4 times 5, and you get 20. Because this is basically 40 times 1 plus 40 times 9 is equal to 4 times 100, basically. So like 4 times 4 plus 4, so 4 times 5. Okay, 33. Multiply the whole numbers. 8 times 7 is 72. 9 over 9 times 5, 77. 8 over 8 times 5, 82. And then multiply the fractions. 82 and 25 over 72. Okay, 14 squared divided by 7 squared times 3.5 squared. This thing right here can be combined to make 14 over 7 all squared. And then you have your 3.5 squared, which is equal to 2 squared times 3.5 squared. And then you can combine your 2 and 3.5, multiply them together because you're multiplying this stuff right here, and you get 7 squared, which is 49. 35, you take out the greatest common square. So in this case, you can take out 16 to leave square root of 2, 4 square root of 2, and in this you can take out 36 to leave square root of 2, so 6 square root of 2. And then you just divide it. The square root of 2 cancels out, and you get 2/3. This right here is equal to 2,200 minus 3 times 3, and then you're adding back on 3 times 3. So it's really just 2200 times 3. Positive geometric mean of 14 and 4 is 2 square root of k. What is k? Well, square root, geometric mean is square root of the numbers multiplied. So square root of 14 times 4. To figure out what we're taking out, it's easier to simplify it into your prime. So you have 2 power to 3 times 7, which means you can take out a common 2 squared and leave 2 times 7 in there. So k is 14. 38, sum of arithmetic series. This would be the series 1 plus 2 plus 3 plus etc. all the way to plus 29, except it's multiplied by 2. So you use this, so you do the same thing as you did if it was from 1 to 29, except now you multiply by 2. So 29 times 30 divided by 2, and then multiply back by 2, which cancel each other out. So you just have 29 times 30 equals 7 or 870. Product of 2 and some number and 8 equals the sum of some number and 7. That number is what? You're just writing this equation right here. Simple enough. 311 gallons of ice cream is how many cups? A gallon is 4 quarts. A quart is 2 pints, and a pint is 2 cups. So that all adds up to multiplying 311 by 16, which you can kind of imagine is somewhere around 5,000. It's close enough, easily. Okay, tens add up to tens trick. 3 squared is, oh, okay, I made a mistake writing this. Bad. I thought it ended with a 4 or something. So 3 squared, like I showed here, right is 909. And then you have your tens multiplied by each other plus this ones place 3. And I already described why that happens on the last two, kinda. But you kind of understand how you can prove this stuff. Like imagine 20 times 20 plus 3 times 80 plus 3. Let x equals 2 minus y, and 2y is equal to x plus 7. It's easier to start figuring out what y is first. Replace this x right here with 2 minus y. 3, you do that, you get 3y is equal to 9, y is equal to 3. And then you can see that x is equal to negative 1 because of that. 7 powered to 4 in base 7 would be 1, 0, 0, 0, 0, because 1, 7, 7 squared, 7 cubed, 7 powered to 4. And then you're subtracting 1, so you have 6, 6, 6, 6, 6 here. Because since it's base 7, once you get rid of a number, you basically, oh, why is it hard to talk? And I shouldn't be proving this much stuff, but once it's base 7, you have to add 7 and then subtract 1. So 7 minus 1 gets you 6. Now this is a 6. And to do that, you had to take 1 off of that, take 1 off of that, take 1 off of that, till everything's just 6, 6, 6. Okay, given this series, find k. This is a split series, as it turns out. So you can imagine this term, this term, this term, and this term as one part of its own series. And then this one, this one, this one, and k is part of another series. The first series is continually adding 4 to each term. The second series is continually adding 2. K is equal to 8. Okay, 1, you can notice these are alternating square cubes, so they have the same distance from 0 and 9 respectively, and they're powered to an odd number, so you know they're going to cancel each other out and form 0. Or you can actually just take the remainder. 27 mod 9 is 0. 6 powered to 3 is equal to 6 powered to 2 mod 9 times 6. This is 36 mod 9 is 0. 0 times 6 is 0. Everything's 0. 31 times 14 over 17. Well, 14 over 17 can be rewritten as 17 minus 3 over 17. So you have 31 times 31 minus 93 over 17 if you distribute that. And then you had to add on 6 of your whole numbers, multiply by 17 to turn into a fraction. 25 plus this is equal to 31, in case you can't see that. And then now that you have that, you can subtract that from this. You get 9 over 17 as your fraction and 25 as your new whole number. 15, this is, or it's 47, this is alternating squares. So for alternating squares, you take the last term, 16, multiply by that last term plus 1, and then divide by 2. So 15 times 8 is 120. Oh, I did forget. I made it, I told you to make it negative, but then I didn't do it on the answer. Okay, yeah. But because the last number is negative 225, because it's negative 1 power to 15, in that case, so because of that, the actual answer is negative as well. The product of the roots is what? Okay, product of the roots is this last number over here divided by this coefficient. That's just 1 in this case. So 8 over 1. And then because this is cubed, the roots multiply. Basically, what's happening is the negative roots are being multiplied by this to get 8. So there are 3 roots to this equation. As such, you have to multiply that negative root 3 times so you get a negative value. So yeah, the product of the roots is negative 8 in this case. Find the sum of the reciprocals of the first 8 triangular numbers. Sum of the reciprocal of triangular numbers, 2 times your last number over 1 plus your last number, 16 over 9. That's one of the few things I can't prove, but it's easy enough to remember. I could probably prove it if I wanted to take the time to do it. Okay, 39 times 139 plus 40 times 139. This is pretty close to 80 times 140, right? 8 times 14 is 112, and then 2 zeros at the end. And that'll put you easily in range. Actually, probably not as easy as I think it would. How close is this? Let me see. Yeah, you're around 25, or you're around like 2.5% over, which is still pretty fine. Okay, this is another one of your repeating tricks. 14 and then only the 4 is repeating, which means you subtract this 1 and you divide it by 90 instead of 99. So 14 minus 1 over 90 plus 1 over 9. Change this to 10 over 90 and you get 23 over 90. Okay, this is sum of geometric series. The sum of the geometric series is the first term times 1 over 1 minus your common ratio. So each number is being multiplied by 1/5. So 1 over 1 minus 1/5, 1 over 4 over 5, 5 over 4 times your 1/5, 1 over 4. Okay, this, if you add in base 8, you just get 121. And then you multiply by 3 to get 636, or 363. Not too bad. I mean, if you don't know how to add in base 8, it's pretty similar. 7 plus 2 is 9. So you put a 1 and then carry a 1. Similar, except you will go over at 8 instead of 10. 3 minus 4i times 1 plus 2i is a plus bi. Then a plus b is what? Okay, in this case, just use FOIL. 3 times 1 plus negative 4 times 2 made negative because it's multiplied by I powered to 2. So 3 minus negative 8 uh, plus negative 4 times 1 plus 3 times 6, or 2. And then if you do that, you get 13. 55, sum of Fibonacci. Sum of a Fibonacci series is this number times the last number times 2 plus the second to last number minus the second number. So if you do that, it's easier to imagine 398 as 400 minus 2 times 2. Then you're adding 246, subtracting 6. Simplifying efficiently, you can get 800 plus 240 minus 4, which is very easy to do in your head to get 1036. 56, just plug it in. 2 times 16 minus 2, log base 4 of 16 is clearly 2. If you don't know what log base is, talk to your algebra teacher, like the man. 2401 has how many positive integral divisors? Well, what you do is you first write everything in terms of its prime. So this is 7 powered to 4, because you can imagine this is 49 squared. If you know that, then, and 49 is 7 powered to 2, so 7 powered to 4. And then for each prime, you take the exponent, this 4, add 1 to it, and multiply them all. There's no other prime, so it's just 4 plus 1 is 5. Okay, 58, 60, power to 16, divided by 31 has a remainder of what? Well, okay, 29. This is equal to 29 power to 16 mod 31, and 2 power to 5 mod 31 is 1, which means it resets every time 2 is powered to 5. So now you can take this 16, find a remainder when that is divided by 5, so which is 1, and then just do 2 powered to 1 to get 2 as your remainder. A regular entagon has an exterior angle of measured 22.5 degrees on how many sides? Well, an exterior angle is 360 over the number of sides. So if it's a bit hard to figure out what value 360 is divided by to get 22.5, multiply this by 4 and you get 90, which is clearly 4 sides. Then no, you divide by 4, so you have to multiply by 4 to get the correct number of sides of 16. 60, cube root. Consolidate your values into groups of 3. This is irrelevant. This is kind of relevant. Well, it's not relevant, but the position is. So write a 0 here. This position will be relevant. This is a decent bit less than 3 power to 3, because 3 power to 3 is 27. So I would go 280 in here. 3 times 7 factorial minus 7 times 6 factorial. If you multiply it by 7, divide by 7 over here, you get 42 times 6 factorial. And now everything's in terms of 6 factorial, so 42 times minus 7 gets you the answer of 35. 3 square root of 3 plus 5 square root of 3 is 8 square root of 3, right? Oh, I guess I should tell you how I got that. You take out the largest square, in this case 3 squared, so 9, 3 square root of 3, and then you take out the large square here, 25, plus 3 plus 5 square root of 3, you get 8 square root of 3, and you have to put the 8 back in, so 8 squared times 3 gets 192. Basically, you have to square a value to move it in or out. The harmonic mean of the arithmetic mean of that and the geometric mean of that is what? Well, the arithmetic mean is 10. The geometric mean is the square root of 4 times 16, which is 8. So an interesting trick for harmonic mean of two numbers, what you do is you multiply the two numbers, that's your numerator. You take the average of the two numbers, that's your denominator. 80 over 9, or 10 times 8 over the average of 8 and 10. Cosecant of sine negative 1 of 1/2. Cosecant is 1 over sine, so you're basically just doing 1 over 1/2. So 1/2 power to negative 1 is 2. Squares to a triangle as an octagon is to a polygon of how many sides? Well, 4 multiplied by something gets you 3, and 8 multiplied by that same thing, this is multiplied by 2, so this has to be multiplied by 2 to get 6 sides. Okay, this is your x cubed plus y cubed, your weird trick that appears once per test. You square this value right here. You subtract it by 3 times this value, so 49 minus 3 is 46. Then you multiply it by that value again. Instead of multiplying 46 by 7, it's easier to do 50 minus 4 times 7, 350 minus 28, 322. Okay, 23 divided by 3 has a remainder of what? This is your remainder of 9 trick because it's 1 less than the base. So you add up all the digits and take the remainder when that's divided by 3. So in this case, 2 plus 2 plus 3 mod 3 is 1. The second term of this expansion is that, sum of p, q, and r. The second term is going to be your x cubed, x or the 4y term, because your first term is x powered to 5. Second term is x powered to 4y. So you simply do that, 2 powered to 4, 2 powered to 4 from this 2 here, multiplying by 1 powered to 1, this one imaginary coefficient there. And then you multiply it by your 5 combination 4, because it's the x powered to 4 term, so 5 combination 4 is 5. Then you get, if you do that, you get 16 times 5 to get you 80, And then these two are going to add up to 5 because that's just how it works when you're this exponent. It's the x power to 4y term anyway, if you don't want to understand that, I guess. 4 plus 1 is 85. Okay, matrix, this 6 value is gotten by this minus that. 4 minus y is equal to 6. Easy enough. Okay, this is to me, this is slightly more than 5.5 times 25, because you have to add a bit here, subtract a bit here. But this is already pretty close to 5.5. In reality, there's not much difference. 5.5 times 25, that's pretty close to it's about half more than 125. Or it's like 125 plus 1/2 of 25. 140 is clearly in range, and then you have to multiply by the 100 right here. Okay, if f of x is equal to this stuff right here, what is f negative 1 of x? You just replace this with -1, and then you have to move this over, multiply each side by 7x plus 4, and then you just have to solve it. It's one of the harder problems to do in your head, basically. But if you do that, you get x is equal to -1. Okay, integral of a linear value. Since it's linear, that means you can do a special trick where you take the average of the bounds of the integral, which in this case is 0, plug it in, and then multiply by the distance between the bounds. So 2 times 0 plus 1, 1 times 2 is 2, and that's your answer. You can, if you want a proof for that, I can show you. In fact, if you want a proof for any of these, please ask me, because personally they help me remember, so they might help you remember. I change 0.23 base 5 to base 10. Okay, well, this can be imagined. This is going to be over 5 squared because you're going 1/5 and then 1/25. So 2/5 times 5 to put it over 25, 10, plus 3, so 13 over 25. For pennies or toss, what are the odds of getting all tails? Well, first we'll figure out the probability of getting all tails, which it's 1 over 2 for an E dice flip. So 1 over 2, all power to 4, is 1 over 16. So then because it's odds, you have to subtract this value from the denominator. So you get 1 over 15. 76 is your cubes trick. You go digit by digit. Because there's a 0 here, you can do this. You can act in terms of 2. So 1 cubed times 3 combination 0, which is just 1. So 0, 1. And then now there's 100th place being added on. 4 times 1 squared times 3 combination 1. So 4 times 3 is 12. Now you have 200s being added on. 4 squared times 3 combination 2, or 3 combination 1. They're both the same thing, is 3. So 16 times 3 is 48. And then finally, you're using all three of these, or all the hundreds, so 4 cubed. And then times 3 combination 3, which is 1 again. Any number combination itself, by the way, is 1. And it's 3 combination. N combination k is equal to n factorial over k factorial over n minus k all factorial. Okay, this is just plug in your values. Or recognize that since this is x squared, these two are going to be the same thing, and then just do f of 0 to get 1. If x is equal to that, find f prime of 4. Well, take the derivative, 2x plus 2, plug in 4, you get 10. 222 times 2 over 27. 111 over 27 is equal to 4 and 1/9. So we're going to be doing everything in terms of that. This is 111 times 2, and this is 1 over 27 times 2. So 4 plus 1 over 9 times 2 times 2, 16 and 4/9. And finally, you're just writing all these values. 4 over 9 times 100 over 125 times 900. Simplify out the values that matter. You get 8 times 400, and you get 3,200 from that. Okay, that was the test. I hope you enjoyed. If you want to hear any proofs for the stuff to help you remember them, or if you want to ask me for any specifics or a deeper dive into the question, then please leave a comment or talk to me in person, and I'll try to answer them to the best of my abilities. Thank you for watching.